Okay, so we're going to go over parallel and perpendicular lines. So what you have in front of you is two pairs of lines. The first pair here on our left are y equals 1 half x minus 1, y equals 1 half x plus 1, and the one here on the right is y equals 1 half x plus 2, y equals negative 2x minus 1. All right, and after figuring out how to graph or learning how to graph them, it should be clear which one is which. But for this pair, this is what we call parallel lines. And these are what are called perpendicular lines. Okay, all right. Now let's see what what makes them have these characteristics with each other. Right. So if you notice parallel, right, a parallel line will never intersect. Parallel lines will never intersect. Right, now, if we look at the equations of these two graphs, right, the two lines, we'll notice one thing here. Right? Well, the thing about these two is that they have the same slope. They have different y-intercepts, so we can think of them as crossing the y-axis at different points. If they were the same point, then it'd just be the same equation, right? But the rate as which they change, right, the slope is the same, right? So they have the same rise and the same run, right? So given that they cross at different points in the y-axis, they're always rising and running at the same rate. So they're never going to intersect each other, right? So the way we can tell that two lines are parallel is that they have equal slopes. Okay, so this other occurrence here is they intersect, right? So really we have two options with lines, right? They either intersect or they're parallel, two distinct lines. Okay, now in this case, perpendicular lines, they are intersecting, right? But they intersect, the way they intersect is special here. These intersect at a right angle. All right. Now, how do I know when this occurs? Well, this occurs if we take a look at their slopes. Right? They're not the same, but they are related in a particular way. All right. The way that I can tell when two lines are perpendicular is their slopes are negative reciprocals of each other. Right? Not just reciprocals, right? Because the reciprocal of 1/2 is 2, negative reciprocals, right? So you take the reciprocal and then you put a negative, and vice versa, right? If we have negative 2, take the reciprocal, put a negative in front of it, and that gives us back to 1/2. Okay? All right. So if we were asked, let's say, for example, to, let's see, we were asked to write an equation a line parallel to g of x equals to 3x minus 1 and passing through the point 4, 9. Okay. Now, excuse me. Okay, so recall here, when trying to determine the equation of a line with a slope and a point, right? And we can use the point slope form. I think here, and if you recall, point slope form was y minus y1 and x minus x1, right? Where x1, y1 is a point on the line, and then the x and y without the subscripts, those are the variables, right? X being the independent, y being the dependent variable. Okay, now I have a point, right, that gives part of our problem. Now we need a slope, right? Usually I would need 2 points to calculate the slope, but here I'm given instead this alternate piece of information, parallel to 3x minus 1. All right, well, if it's parallel, I know it must have the same slope. So I actually know the slope as well. All right, so now I can just plug these in, right? Y minus 9 equals to m, which is 3, x minus 4. All right, and then here let's simplify. Let's get in the slope-intercept form. 3x minus 12, add 9 to both sides. And we get y is equal to 3x minus 3. All right, and these will be parallel, right? They have the same slope, right? Different y-intercepts, so I know it's not the same line. All right, okay, so that's how we work with parallel lines.